Hello guys, and welcome to another video. Today we're going to be solving problem 263 on Leetcode. It's called Ugly Number. But before that, I would like to wish everybody a Merry Christmas. It is Christmas Eve after all. So this program states, write a program to check whether a given number is an ugly number. Ugly numbers are positive numbers whose prime factors only include 2, 3, 5. So this should say any combination of this, right? Because you can see here that 2 times 3, right, gives you 6, but that returns true, and 5 is not included. So you can have any of these numbers as a sequence of primes, okay? So like here. So what we can do is apply bit shifting to this problem. For example, like here, we can see that 8, right, is just a power of 2. So we can actually use some bit shifting for that. And we can also use some bit shifting for even numbers, right, that divide into 2, because we could just shift that by 1 and you would get 3, right? So if you right shift 6 by 1, you're dividing that by 2, you end up with 3. Okay, so these are little properties that we can use. So let's get started. Let me copy this little function definition here because it'll be easier for me to use that. So far I've created a file using the Dart programming language, and I'm just going to go ahead and paste that here. And you know what? I'm just going to go ahead and say int value, all right? And then what I'm going to do is create an optional parameter. And this is going to be primes. All right, and this is just going to be a list of 3 and 5. The reason is because 2 is a special case, so I'm going to handle that a little bit differently. All right, so the first thing is to define ugly number, right? So it says an ugly number cannot be less than or equal to 0. So we're going to say if the value, right, is less than or equal to 0, then we just want to go ahead and return false. Okay. Next thing I want to do is we want to go ahead and check for powers of 2. So if the number is 2, 4, 8, 16, 32, 64, 128, 256, they're all powers of 2. Okay. So we can use bit shifting for that. So what we're going to say if, right, we're going to say value, right, and then we're going to we're going to say value, right, minus 1, and if this is equal to 0, then we're going to go ahead and return true. All right, so how does this work? I will show you guys later on after I'm done building this function, right? But the thing is that if you want to find if a number is actually a power of 2, you just take that number and then you AND it with that number minus 1. And that will then give you all zeros, okay? If it doesn't give you all zeros, then it's not a power of 2. Next, what we want to do is actually take care of even numbers, okay? So we're going to say, right, while, okay, value, right, and 1, if that is equal to 0, so that means that this number is actually even. Okay, so what we're going to do is that if the number is even, we want to say number or value, right, and we're going to right shift that and then put that value back in by 1. So remember that right shifting by 1 means dividing by 2. Okay, so if we have 6 and we right shift, right, then we're going to say 6 divided by 2 is going to give us 3. And let's actually just create main here, and then I will dive into that and just show you guys before I move on. So if we say print, and then we say 6, and then we right shift 6 by 1, it's the same thing as saying 6 divided by 2. Okay, so let's run this. And you see that we actually get 3. So what I'm doing here is that I'm saying, well, if 6, right, is even, right, I want you to go until it's no longer even. So let's say we have 12, right? then we're going to right shift it by 1. That's going to give us 6, right? So remember I said right shifting by 1 means dividing by 2. So this is going to give us 6. Then I right shift 6 again by 1, and this is going to give us 3. Now we can just come here and run 3 just once, okay? So by using bit shifting, we can optimize how the solution actually, the performance of our function, okay? So once we're done with this, right, we're going to say, we're going to just go to our for loop. The reason why I didn't use bit shifting for 3 and 5 is because writing a modular function for those get really messy, and so I wanted to keep things a little bit more simpler, right? Sometimes complexity it's best avoided if you can. So the index is less than, and then we're going to use primes dot length, right, and then index plus plus. So here, what we want to do is apply. So we're going to apply the same thing that we did for this top section here. However, we're just going to use the mod operator because I didn't want to build one. So we're going to say while the value, right, mod, and then we're going to do primes index is equal to 0. What we're going to do is we're going to say that the value, right, we're going to divide and put that value back with the number that we find in the list. So here it's going to be 3 for the first part. All right, and then eventually all we need to just do is return, right, the value equal to 1. So let's say that we have 6, right? So what it's going to do is that it's first going to go ahead and bit shift 6 by 1 up top. So we're going to end up with 3, and then we come down here. So right now, value mod 3, right, which is the first thing here, is equal to 0. So we just divide that. So if we have 3 divided by 3, we end up with the value being 1 always, right? So that's taken care of. So let's actually go into the this one right here. Okay, so what I'm going to do here is just copy this for a second, and we're just going to go ahead and do print. Okay, and I'm just going to paste it here, and I'm going to change this value to, let's say, 5 and 5. All right, so we should expect this to return 0, and this is how you find if we should expect this to return actually 1, because 5 is not a power of we should expect this not to return 0, right, because it's not a power of 2. All right, so you can run this and you can see that it actually returns 4. All right, I was a little bit confusing this with the AND operator. So with this part right here, it either returns 1 or returns 0. Okay, but here it can return anything. So let's try so do 4, and then we change this to 4. All right, so this should return 0 because it is a power of 2. And if you try something like 16 and 16, right, it should give 0 as well. So now we go with the figuring out if a number is odd or even, right? So we can just use this here. So what happens is that if we take the number and then we just AND it by 1, right? So since 16 is even, what it's going to do is that it's going to return 0. Okay, so let's run that. You can see return 0. If this is odd, then it's going to return a 1. All right, and it doesn't really matter which odd number you pass in, it's still going to return just 1. Okay, so if it's even, returns 0. If it's odd, returns 1. The other thing is that the power of 2 is actually a little bit different. Okay, and yeah, that's it. All right, so once we're here, we're here, right, we just say, well, if the number is even, then we just right shift. So if 4 is even, we just right shift. So we're going to right shift 4 by 1, so we end up with 2, right? Then if we right shift again by 2 by 1, then we just end up with 1. Now 1 is actually odd, so we exit here, all right, and then we go here, and then we check, but eventually the value is still 1, so we're good. Okay, all right, so that's how this actually works. So what I'm going to do here is just go ahead and call the print function again, and it's ugly. And you can see that we have 2 parameters here, but this one is an optional parameter, right? So that means that if we don't pass in any values here, it will not, it will just use the default values in there. So what we're going to do here is just pass 6 here. And remember that 6 is actually an ugly number. So let's run this. And you can see that returns true. And then we can try 8 here. And that should also return true. And then 14 was not an ugly number because it has 7 as a prime. So it's going to go ahead and return false. All right, if you pass in any negative numbers, it will just go ahead and return false here. All right, guys, this will be it for this tutorial. I hope you guys enjoy it. I hope you guys are actually enjoying your Christmas Eve and not being like me actually making tutorials. Well, if you enjoyed this tutorial, just give me a thumb up. If you have any questions, please leave it down in the comment section below. And I told you guys should get the Hacker's Delight book. That would help you a lot with understanding how to use bitwise operators. All right. Okay, guys, this will be it. And don't forget to subscribe. See you guys. Bye-bye.